All right, in 7.2, we're going to continue our discussion about confidence intervals, and specifically the margin of error part. What is it we add and subtract to our point estimate to give us a great interval that the real parameter may be in? So what affects that? Well, look at the next slide. The claim of 95% confidence means that we're using a method that successfully captures the parameter 95% of the time. To interpret the confidence level C, that could be any confidence level they give you, you say, if we were to select many random samples, notice this phrase, many random samples from a population and construct whatever confidence interval using each sample, about 90% or whatever percent of the samples would capture the parameter that we're wanting, okay, means or proportions or medians, whatever. But you have to take many, many samples, calculate many, many intervals, and you would find that a certain percentage of those intervals would actually capture the real value. Okay? So make sure not to interpret confidence intervals when you're asked to interpret a confidence level. Okay? You've got to read to make sure. The interval one is the one where we say we are 95% confident. The level starts off if we were to select many random samples. Okay, so got to read carefully and make sure you use the right interpretation. Confidence levels describe the process used to make the interval, not a particular interval. So be really, really careful. Catch that. Okay. So what affects this? Well, be careful. Caution. The confidence level does not tell us about the probability that a particular confidence interval captures the population parameter. It's not a probability. Okay. It's not a 95% chance. It's not a probability. Okay. The confidence level reveals how likely it is that the method that we're using will provide an interval that captures the population parameter if we use it many times. However, in practice, researchers usually calculate just a single interval for a given situation. Okay. So what does affect this? In general, we prefer short intervals, confidence intervals. That is, confidence intervals with a small margin of error. So to reduce the margin of error, we can change two factors. You need to write these down. Change the sample size, and you can change the confidence level. We can get a more precise estimate of a parameter by increasing the sample size, okay? Increasing the sample size, and larger samples yield a narrower confidence interval at any confidence level, all right? So keep that in mind. Smaller margin error happens when we have a higher. To reduce your margin of error, you can increase your sample size. All right? To reduce your margin of error, you can increase your sample size. Now, when we calculate a confidence interval, we include the margin of error because we expect the value of the point estimate to vary somewhat from the actual parameter. However, the margin of error accounts for only the variability we expect from random sampling that we've seen. The margin of error does not account for any sources of bias in the data collection process. Okay, this goes back to when we talked about taking samples and taking good samples that were not biased one way or the other. The margin of error, the wiggle room we put in a confidence interval, does not correct any of that. It only corrects what happens when we get different samples from just the regular sampling process. All right, the principal of a large high school wanted to know how many hours students spend doing homework during a typical week. Based on a random sample of 100 students, a 90% confidence interval for the mean number of hours doing homework for all students is 2.3 to 4.1 hours. Interpret the confidence level. Level, okay? So we would say, if the principal took many random samples and constructed a 90% confidence interval, you can abbreviate confidence interval for each sample, then we would say about 90% of these intervals would capture the true mean number of hours doing homework for all students at the school. All right, it's a lot. I know. When they ask you to do level, it's a lot of writing. So remember, you have to mention that the investigator or the principal, whoever, took many random samples, constructed many confidence intervals for each sample. About 90% of those samples, of these intervals, sorry, would capture the true mean number of hours doing homework for all students at the school. Same scenario, the principal's trying to estimate how many hours they spent on homework, so look at A. Explain what would happen to the length of the interval if the confidence level were increased 99%. Okay, so let's think here. Visualize that target we talked about. Okay, here's our sample mean. And originally it was a 90% confidence interval, right? So if it's 90% here, there's our margin of error. If I want a 99% confidence interval, my target gets bigger. So what's going to happen to your margin of error length right there? Is it getting bigger or is it getting smaller? That margin of error is getting wider, okay? The interval gets wider as the confidence level increases, right? So the interval gets wider as your confidence level increases, all right? Now B, explain what would happen to the length of the interval if the sample size increased, okay? This is what we talked about on the previous slide. We said if the sample size increases, sample increase, the interval, right? The interval will decrease. So the interval will get narrower or smaller, okay? We said the sample size increases, the interval decreases, and the interval will get smaller. All right, so hopefully this gives you some good ideas and concepts, and we'll talk more about this in class, and we'll see you then.